Number one, energy is the ability to do what? Okay. 1 mark. What's the amount of work it would take for a 55-kilogram student to climb? You know, climb, that's lift. The amount of work is going to be mgh. Again, I said to you, I'm not saying that the force of gravity is what we're doing work against. I'm saying if we draw the free body diagram, the lift force has to be the same size as mg. So we said, we'll just call it mgh, even though it's not in the same direction. Because I had somebody say, Mr. Dewitt, gravity's this way, height is this way. Why aren't they negative? Because if they're in opposite directions, aren't they supposed to be negative? The force we're talking about is the same magnitude as mg. It's pointing up. So it's going to be 55 times 9.8 times 6. 55 times 9.8 times 6. You'll get 3,230. If you added the 4, that's fine. Units? Joules. Is that right?
Yeah.
Okay. Multiple choice question. A ball is above the ground and fall. What's its total energy? I guess total energy is just going to be the potential plus the kinetic at that moment in time. Not a change in. Looks like the potential is going to be mgh and the kinetic is going to be a half mv squared. It's going to be 2 times 9.8 times 5 plus 0.5 times 2 times 5 squared. Can I do this in my head? It's going to be 49 times 2. It's going to be 98 plus 25. Is it 120?
Yeah.
123, I think.
Yeah.
Yeah. Okay. Okay. I never explained total energy to you, but I'm going to argue you've learned what the word total means, I hope. Okay. All right. Now we're doing a force versus position graph. It wants the work done moving an object from 0, which is the beginning, to 5 meters. You know what? It's going to be this total area. I'm going to break it up into a triangle and a rectangle. My high-tech notation, quiet please, I use a 1 and a 2. Area 1 is a triangle. It's going to be base times height divided by 2. The base, it looks like we're going up by ones, so the base is 3. Is the height 2? No, it looks like that's 200 divided by 2. The area of the first shape is 300. The area of the second shape is going to be length times width. Looks like the length is 2 and the width is 200. The area of the second shape is 400. I think I can add this together in my head. Is it B? Yes? So that's how much energy was poured into this object. Where did that energy go? Speeding the object up and heating up the floor. But if it's frictionless, also level floor, so none of it went into changing its height. Okay? If it's frictionless, all of the energy would have gone into kinetic, but maybe there's some friction. It says if the graph in question 4 represents the work done on a mass, find the speed when it reaches 5. The mass is initially at rest. I guess we'll assume no friction. So what we're really going to say here is work equals work. Okay, Alex, I'd like you facing the front, please. Thank you. And work is going to be the area, which was, what was it, 700? That's going to be the change in potential plus the change in kinetic. But it said level ground, so I can do that. What's change in anything? So it's going to be 700 equals a half mv final squared. Why didn't I bother writing a half mv initial squared? It says it started at rest, so okay. I guess I could either give you the speed and say find the mass, or I could give you the mass and say find the speed. Here they gave me the mass, so I guess it's going to be 2 times 700 divided by, what's m? 4. That equals v squared. So I guess I would square root. It's going to be 2 times 700 divided by 4, square root of 350, and I get 18.7. Is that correct? Correct answer is A. Okay. What could I ask if this was a written question and as a follow-up? I could say something like, suppose the object is only traveling 12 meters per second. How much energy was lost to heat? Now you could turn it into a conservation of energy, because you would know how much energy you started with, 700 equals whatever you've got for kinetic plus heat. Okay. An escalator is used to move, what do you want me to find? Power. Power is work over time. Now, if we're lifting people up on an escalator, I'm pretty sure that's just going to be mgh over time. What's m? I'll give you a hint. It's not 60. 20 passengers averaging 60. That's the mass. G, 9.8. What's H, 5 or 10? 5, because lifting, we're going against gravity. What's the time? I said per minute, 60 seconds. In fact, if I was clever, I could even do that, and it's going to be 100 times 9.8. It's 980 watts. It's C, yes? Or not? Yes? Okay. What if the motor was rated for 1400 watts? What's the efficiency? You would go 980 divided by 1400 times 100 to make it a percent. That would be the percentage of efficiency. How much work is required to stop a car? Nice try, Duick. 10, I think it's divided by 3.6. 2.7 repeating. Okay. How much work? Well, work equals force times distance. I don't see a force or a distance. Madison, work is also the area underneath the force versus distance graph. Do we see a graph? So what's my third definition of work? This is the third one on your sheet. It's going to be change in potential plus change in kinetic. I don't think it mentions a change in the heights. On a test, I would include the phrase over level ground. Madison, what's change in anything? Final minus. So this is going to be a half mv final squared minus a half mv initial squared. Oh, it's coming to a stop, so v final is 0. Claudia, you can see this one here is negative. This is not, technically this work is also negative. The negative here is saying the car has to lose energy, and it's saying the force and the distance are in opposite directions. What I'm really saying is for a car stopping, when you get to this line, if you want to, you can just say the magnitude work equals a half mv squared. So it's going to be 0.5 times 1200 times, and I'm going to use my answer button, squared. Now, what else could I ask as a follow-up? If I told you the distance the car needed to come to a stop, you could find the force, because work is still force times distance. Or if I told you the force of friction that the brakes were capable of putting out, you could find the distance required to come to a stop, because again, work equals force times distance. I got 4,630? 4,600 it looks like. B? How much work has been done by friction? In other words, how much heat? Well, I know it asks for how much work is done by friction, but I don't think this is a work question. I see a change in the height. I see a change in speed. I see a yucky, curvy path. I think I'm going to solve this for conservation of energy, and I'll solve for heat, which is the work done by friction. So I'm going to go KE initial plus PE initial, KE final plus PE E final plus heat. Which one of these is the energy of motion? Potential or kinetic? So if we're not moving, what's our kinetic energy?
0.
Is there anywhere we're not moving?
Yeah.
Where?
At the very beginning and very end.
Oh! You mean we start out at rest and we end up at rest?
For a second.
That's a bonus for a split second. Not for a second. That would be a fairly long time. Okay. Is potential energy ever 0? Well, right now, initial is here and final is here. I don't think we're ever on the ground. Now, what I could do if I was lazy, because remember I could put the ground wherever I want. I could put the ground right there and have my final height be 0 and my initial height be 0.1. I would get the same answer. But I'm guessing most of you didn't do that. I'm guessing most of you just said, Mr. Dewick, it's going to be mgh initial minus mgh final. That equals heat. I'm guessing most of you subtracted the potential energy over. Hopefully none of you divided it over. And if I crunch that, heat is going to be M 75, G 9.8, 2.5 minus 75 times 9.8 times 2.4. And I said, or you could just look at the height difference of 0.1 and put the ground there. Did you get 73.5 no matter what? 74? Is it A? Yeah. We lost 74 joules of energy to heat. What if there was no friction? What would Tarzan's speed be at the bottom of the swing? Well, again, it's a change in height, change in speed, yucky, curvy path. So it's going to be conservation of energy. But no heat. At the bottom of the swing, I think I can say that because we're on the ground. I think I can say that the potential energy final is 0. And Quinn has already pointed out we're starting at rest. And so this simplifies to mgh initial equals a half mv final squared. Is there an m in everything? So this would also be Tantor the elephant's speed at the bottom, assuming the vine didn't break. We're going to get the speed by itself. So a situation like this, I gave you, Clody, the initial height, and I'm saying find the speed. I also have no problem telling you the speed at the bottom and saying, hey, how high did you jump from? Get the h by itself. I guess technically I could give you the height and the speed and say, what's the gravity of the mystery planet that we're on? I'm not going to do that, but I could. Didn't think of it until just now. I guess to get the v by itself, it's going to be 2gh initial. That equals v final squared, so square root. It's going to be 2 times 9.8 times 2.5. Oh, 7 even? Okay. Ooh, roller coaster. Initial velocity is 4. I'll draw that in so I don't forget. All right. Part A says, how fast is it traveling at the bottom? So I guess our initial is here and our final is here. This is definitely going to be conservation of energy. So it's going to be KE initial plus PE initial equals KE final. Why didn't I bother writing PE final? I think it's 0 and I'm going to be a little bit lazy. Okay, it's going to be a half mv initial squared plus mgh initial equals a half mv final squared. Lena, is there an m in the first term? Is there an m in the second term? Is there an m in the third term? Have you gone on a roller coaster before? Before you got on the roller coaster, did they make you stand on a scale? Why not? If we're ignoring friction, masses cancel. And I'm trying to get the v final by itself. Lena, I would choose to go times by 2, times this by 2, times this by 2, because then I get our old friend vi squared plus 2ad, because g is an a and h is a d, equals VF squared. It's VF squared equals VI squared plus 2AD in disguise square root. It's going to be, how fast were we traveling at the beginning? 4? No. Yeah, 4 plus 2 times 9.8 times 18. This might work out evenly, does it? No. 4 plus 2. Thank you. Thank you. I missed that. 4 squared plus 2 times 9.8 times 18. No, this won't work out evenly. Did you get 19.2? So I would give you 3 out of 3 if I saw that. Otherwise, I would probably give you a half mark if I saw that you would use conservation of energy. I'd give you a half mark if you had substituted the equation in, even if you didn't bother canceling out the m. You don't have to. I would give you a half mark if I saw that. I would give you a half mark if I saw that. And I would give you 1 mark for the answer. Something like that. How fast is it traveling at the top of the second hill? Sarah, there's 2 ways to do this. The best way would be to let that be the ground and let your height be 8. How many of you did it that way? Couple of you. Most of you probably did it the longer way, so I'll do it the longer way. The longer way, we start out with conservation of energy. And unfortunately, nothing cancels. So it's going to be mgh initial. Sorry, go in order, Mr. Dewick. A half mv initial squared plus mgh initial equals a half mv final squared plus mgh final. Lily, is there an m in everything? Okay. Pause for 1 second. Okay. Oh, Lily, have you gone on roller coasters before? Before you got on the roller coaster, they make you stand on a scale? Why not? If we ignore friction, mass is canceled. Little kids and grown-ups. What are we trying to get by itself? This is around where my love for getting something by itself almost hits a wall. But maybe not. I mean, it's going to be 0.5 VI squared plus GHI minus GHF all divided by 0.5. I think that equals, I forgot the squared, Mr. Dewick, VF squared. Is that correct? I think so. I might start to turn this into a number, and like I might start actually crunching numbers 1 line earlier and not getting everything by itself. This is right around my tipping point where I start to say, a lot of work. But okay, how to get rid of a squared? Square root. So it's going to be 0.5 times 4 squared plus 9.8 times 18 minus 9.8 times 10. Was it 10 or 8? 10, right? Yeah. All divided by 0.5. Stop making noises, folks. Thank you. 0.5 times 4 squared plus 9.8 times 18 minus 9.8 times 10 equals divided by 0.5. Square root of that? Whew. Well, I know it's going to be less than 19.2 because we've gone higher. 13.1? Is that right? If you got that, I would give you 4 out of 4. Otherwise, I'd probably go 1 mark for that, 1 mark for that, probably 1 mark for that, and 1 mark for the answer. Can you give yourself a score out of 16, please?